projectile. Hello everybody, hello my friends. Today I would like to share with you another session that include in mechanics. Remember, mechanics is divided into two parts: kinematics and dynamics. Kinematics is the motion of body without considering the cause, whereas dynamics is the motion of body with considering the cause. Deals with the motion of body with considering the cause. So the lesson title for today included in dynamics, and it is called projectile motion. So you may ask yourself, what is a projectile motion? A projectile motion is the motion of the body within two dimensions, mean x and y plane. So this is what we call projectile motion. So I need to discuss one equation of that motion. So here we consider two cases: when the body moving upward and when the body moving upward or on y-axis, and when the body moving on x-axis or horizontally. So we have vertically and horizontally. So let us start on when the body is moving upward. We have the parameter that we have to consider. The first one is acceleration. It is ay, which is equal to minus g, and g is gravitational acceleration and it is constant. And also, what about velocity? Vy, velocity of projectile body at certain time, is equal to initial velocity on y-axis minus gt. And the third one, it is the height or maximum height, which is equal to minus 1/2 gt squared plus initial velocity times height. So this equation will help us in delivering the final equation, the simplified equation that we need here in projectile motion. So let us consider this drawing our plane xy and y, x-axis, y-axis. So let us consider also, this is the path of a projected body. This one, it is a path of trajectory, projected body starting from the origin 0 and start with initial velocity, the magnitude take u, and this magnitude, it is a vector, has its component, which is uy, and which is on the horizontal axis we have ux. So this is starting velocity or initial velocity. Initial velocity on y-axis is equal to, here we have angle theta, the angle or projectile angle, the angle at which the projectile body makes on the horizontal, and the angle projectile body makes on y-axis, and the uy is equal to u initial, which is this one, magnitude, times this sine theta, and the ux is equal to u0 cosine theta. This is another great important equation. Again, what about when the body reaches at a maximum height? At maximum height, what will happen to the velocity and also to the time and height? So when the body reaches here, it is where the maximum height is located, or maximum point is located. If you look well, the body tends to descend. It's falling down slowly by slowly, time by time. Mean that the velocity Vy is reduced to 0. Since the velocity causes the body to move upward becomes 0, what will happen? The body will fall down. So at maximum height here, the velocity is 0. So say velocity is 0, and we know that velocity at certain time of projected body is equal to u initial y minus gt. When this one becomes 0, we will have 0 equal to u initial minus gt. And remember, u initial is equal to u0 sine theta. We can substitute this one in this equation, and we will have 0 equal to u0 sine theta minus gt. So from this equation, we can find the time at the height maximum. So how you can find? You can separate the members, and the gt is equal to u0 sine theta, and we find the value of t, which will be equal to u0 sine theta over g. So this time is the time when a projected body is at a maximum height. Time required for projectile body to reach to the maximum height. It is calculated using this formula. U0, it is the initial velocity of projected body sine theta over g. And remember, g is a constant. It is gravitational acceleration, which is equal to 9.81 approximately to 10 meter per second square. So this is another great equation. So this equation can be substituted in height in order to find the formula that we can use in height maximum. And remember that height maximum is equal to minus half gt square plus u0 uyt. So we can substitute the value of u initial and time in order to find the height maximum, and it will be equal to minus 1 over 2 gt square plus u initial on y-axis equal to u0 sine theta times t. And t is equal to this one also, can equal to 1 over 2. This one will come here, will come to substitute here, and it is equal to g and t is equal to u0 sin theta over g squared plus u0 sin theta times u0 sin theta over g. So finally, we found that height maximum is equal to minus 1 over 2g u0 squared sin theta squared over g squared plus u0 sin theta, and this one will be u0 squared sin theta, and sin theta, and this one will be squared over g. So this one can be simplified by these two, and remain with 1 over 2 u0 sin theta squared over g plus u0 squared sin squared theta over g. Look at where we are here. So height is equal to height maximum is equal to 1 over 2. Remember, there is minus 1 over 2 u0 squared sin theta squared over g plus u0 squared sin theta squared over g. So we can sum up in order to find the simplified equation. When we sum up, we will remain with h maximum is equal to, so this one on common denominator will be 2g is equal to u0 minus u0 sin theta squared minus u0 sin theta squared. So this term is the same as this term, but here it is positive. Remember, it is 2 plus 2, because this 2 will be multiplied by here. So when we add together, we find h maximum is equal to this one, remain with u0 squared sin squared theta over 2g. So this is a very simplified, important formula for calculating height maximum, the maximum height of projected body or projectile motion. So this equation is what I need to show you today, where u0 is initial velocity and g is gravitational acceleration, which is equal to 9.81, which approximates to 10 meter per second square. You can use this one or you can use this one, no problem. So thank you for your attendance, and remember to do subscribe to the video in order to get another easily. So on the next session for this one, I will show you how to derive horizontal range, Allah. So thank you. I love you all the subscribers. Thank you for the next session.